Since we're on the topic of destruction, next up, we're taking you to a lab that blows things up. It's at the University of Ottawa, and it's the only facility in Canada that can test how buildings stand up to massive explosions.
Tests in this lab are all about pushing the envelope. Simulating massive car bombs slamming into concrete buildings.
I hope none of this is ever needed.
When hope isn't enough, Murad Sachurlo's lab is ready. It's the only place in Canada that can set up tests like this. Seeing if this concrete beam, similar to what's in most office buildings, can stand up to a 500-kilogram bomb blast.
A 500-kilogram bomb would be typically a car bomb or a truck bomb located at approximately 40 meters in this case. We expect the beam to eventually fail and split into two under shock waves.
The waves are created inside a shock tube, and getting it ready
Yeah, I'm gonna pass out here.
is a bit of a workout. They're opening up the tube to replace the barrier that helps create the shockwave.
They're just aluminum foil, similar to your pop can in thickness.
Air pressure builds behind that foil, and when it bursts, high pressure erupts into the lower pressure chamber, belching out a force equal to an explosion. It's all controlled upstairs, because they can't even be on the same floor as the shock tube. It's too dangerous and way too loud.
Now we're charging the system.
At this point, we're waiting for the pressure to hit our desired level, and then we'll go forwards with it.
The desired level? A pressure difference of more than 100 kilopascals. That could equal truck bomb strength. It was a massive truck bomb that created the worst act of terrorism on U.S. soil before 9/11. More than 160 lives were lost in Oklahoma City in a blast that destroyed a 16-block radius.
We always think of Oklahoma City Murray building because this is where there was a spectacular structural failure.
It's the reason Murad does these tests.
Fire the shot.
The test only took a fraction of a second. But what they learned from it could help shield people for lifetimes to come.
This is truly a successful test.
It shows where concrete strains under extreme pressure.
This is where we have maximum bending.
The information gained here will help create new construction standards in Canada.
We need to stress this back.
But for grad student Eric Jacques, the next test could give him the ultimate data.
This is the last one for what could be the rest of my PhD testing. So I'm done.
Well, you're not quite done yet, Eric. It can take hours to prepare a test in this lab where nothing is easy and everything is loud.
This is our big test now.
Okay, we got it in place. We're ready to go.
They're intended to be doors for entering into critical buildings, and they're intended to be blast resistant.
And there's only one way to find out. Strap them to a simulated 160-kilogram car bomb, see what happens.
These sensors record the motion of the doors, so they're going to tell us how far the door moves outwards as a result of the blast loading. All right, I think we're ready to go.
3, 2, 1.
Blast event occurs somewhere here. It starts to vibrate. Towards the end of the motion of the door, you can see it sort of returns back to its original position. So without going downstairs, we can infer that the door is likely undamaged.
But of course, they have to see for themselves. Amazingly, there are 0 signs of damage.
would certainly protect the occupants inside the building, and it can possibly use for higher levels of protection, even more important buildings.
But no rest for them or these doors in the future.
We're going to keep hitting it until it fails, so we can learn as much as we can.
This is what research is all about, and that's why we enjoy doing it.